In this work, we propose AdaptiveAE, an efficient exposure control algorithm designed for HDR capturing, and address both motion blur and noise during image acquisition. Experimental results across multiple datasets demonstrate that AdaptiveAE achieves state-of-the-art performance. It excels in dynamic scenes due to a blur synthesis model and carefully designed rewards. Thus, our model effectively balances noise reduction and motion artifact minimization, delivering high-quality HDR results. During inference, AdaptiveAE iteratively refines the capturing strategy through 4 stages. In each stage, the agent takes the previously captured LDRs as input and predicts the ISO and shutter speed for the next stage. Specifically, in the initial stage S0, 3 LDRs are captured with exposure value -2, 0, and +2, with arbitrary ISO and shutter speeds, with footnote P denoting predefined baseline for EV0. The agent takes them as input and predicts the parameters for the mid-exposed frame for the next stage and customize the parameters for the underexposed and overexposed frame to have -2, 0, and +2 EV. The footnote X denote that the baseline for EV0 is predicted as X. Then, LDRs are captured according to the selected parameters, and we transit to stage S1. Similarly, the agent takes the taken LDRs as input and predict the parameters for the underexposed frame, customize the parameters for the overexposed frame, and inherit the parameters for the mid-exposed frame. Finally, the agent predict the parameters for the overexposed frame with others inherited from the previous stage. In such a way, our method iteratively improves the result through the stages during inference. As is shown, we perform exposure fusion to the LDRs synthesized according to the predicted ISOs and shutter speeds in each stage to get the intermediate HDR results and calculate the PSNR, which gradually improves through the iterative refinement process. The sequential selection of capturing parameters during auto-exposure is modeled as a Markov decision process, where a CNN-based policy network predicts the ISO and shutter speed. Concurrently, a CNN-based value network predicts state value. Deep HDR is used to calculate the reward for the current policy, and the reference frame for exposure fusion is always the mid-exposed frame. The LDRs are synthesized using our image synthesis pipeline according to the predicted parameters. The entire system is optimized using the asynchronous advantage actor-critic algorithm. We carried out thorough comparisons with other methods. For the dynamic scene on the left, the methods compared provide different ISO and shutter speed predictions, and we synthesized the corresponding LDRs using our image synthesis model. Our trained agent utilizes a different strategy compared with other methods, especially for the mid-exposed frame. The trained agent tends to predict faster shutters to avoid blur in the mid-exposed frame, which plays an important role in the quality of the fused HDR result. We performed exposure fusion to the synthesized LDRs using Deep HDR. Results reveal that our exposure strategy effectively avoids motion blur caused degradation while maintaining a relatively low overall noise level. Our model is robust to different movement magnitudes in different dynamic scenes. For the example scenes presented, which has around 30 and 60 pixels of average movement respectively, our model responds by predicting faster shutters for the scene with stronger motion. Besides, we carried out a thorough experiment on the real HDRV dataset to quantitatively evaluate our model's robustness to motion. As is shown in the chart on the right, our model is more robust to motion than other methods as the average strength of motion in the patch increases. We used a Sony Alpha 7C2 to evaluate our model on diverse real-world scenes. Subjects performed steady, repetitive movements while ISO and shutter speed were manually set for each capture, with the aperture fixed at f2.8. Qualitative results reveal that our method offers noise control comparable to or better than other baselines, while effectively avoiding motion blur that can impair the fused HDR image's visual quality. Thank you for watching.